So that you have to keep in mind, right? So linear combination plays an important role. That is one of the very powerful technique, you can say, right? So linear combination is nothing but what? Only two things are there, right? You are multiplying by scalar with the vector, okay? And you are adding them. So scaling and adding, there are two operations you are doing, right? कितना सिंपल लीनियर कॉम्बिनेशन होता है, मल्टीप्लाइंग बाय स्केलर एंड एडिंग, राइट? ओके, और लीनियर इंडिपेंडेंट में भी आपको क्या करना है, व्हाट यू आर डूइंग देयर, सी इफ यू फेल टू राइट, आई मीन there should not be any kind of linear combination, okay? Remember, I'm just going to show you, right, what is the linear independence definition, okay? Last time I have given you some definition, today I will be giving you some new definition, okay? And I will tell you how to investigate, in fact I have told you also, and we solved one question as well, right? Okay. So if there will be a free variable, last time I told you कि अगर वहां पर free variable होता है तो linearly independent नहीं होगा, that will be linearly dependent, ठीक है? चलो, तो इस सेशन में हम लोग क्या करेंगे, सबसे पहले let me recall the definition of linearly independent. Linear independent, okay. The question of linear independence and dependence, you can say, okay. If something is not linearly independent, so we call it dependent, ठीक है? तो आप लोग ये याद रखना, ये कुछ these are very important concepts in linear algebra, और आगे बहुत ज्यादा काम आने वाले हैं, ठीक है? तो आपको याद रखना है. तो so I will give you some new definition of you can say linear independence, right? So already I have given you linear combination definition, right? ठीक है, fine. Yes, yeah. So let me write here the definition, a linear independence definition, okay? So a set of vectors, okay? So in the question they will mention a bunch of vectors, right? So a set of vectors, right? A set of vectors is linearly independent, linearly independent if, okay, if none of these vectors, okay, can be written as linear combination of the other vector, okay? I hope this makes sense to all, right? So last time I told you lambda 1 v1 plus lambda 2 v2 plus lambda 3 v3 should be equal to 0 if and only if all these lambdas are 0, right? Lambda 1, lambda 2, lambda 3, they are 0, right? So in other language you can say that set of vectors are given, and if you are not able to write them as a linear combination, okay, means that is the linearly independent vectors. अगर आप linear combination लिख पा रहे हो, if you are able to express them as a linear combination, right? Okay, so none of these vector can be written as linear combination of the other vectors, ठीक है? मतलब क्या है, जैसे मान लो कोई एक मैट्रिक्स है, if you take one matrix, let me show you here. मान लो कोई एक मैट्रिक्स लेते हैं, जैसे मान लो एक मैट्रिक्स ये है, ठीक है, 1 2 3, okay, and this is 4, this is 5, this is 6, and you take this as 5 7 9, right? If you look at this, this is one vector, this is second vector, this is third vector, right? So if you combine them, these two, if you take this these two vector, right, if you combine them, you can get this third vector, right? तो जो थर्ड तीसरा वेक्टर है that you can get directly, okay, by taking the linear combination of first and second, right? Okay, so this is not the Li vector. I hope this makes sense to all, right? सबको समझ आया क्या? Li vector का मतलब क्या होता है कि you have to remember, so no vector can be written as linear combination of other two vectors, right? Other vectors you can say. तो आप मैट्रिक्स में देखते हो कि if there are two pivots, okay, rank is 2, okay, and we call it there are two linearly independent rows, right? There are two linearly independent columns vector, right? तो आपको याद रखना है कि अगर मान लो if you are getting some row or column, right, in the matrices, right, by combining some other row or column, right, it means what? The vectors are not linearly independent, right? Vectors are linearly dependent, okay? So please remember these definitions. These definitions are important, right? Just मान लो, let me give you some other examples as well. So examples are like, suppose we have got v1 equal to suppose we have got some set here, v1 equal to 1 and 0, and v2 equal to 0 and 1, right? So see guys, they are linearly independent, okay? They are Li, right? They are Li, okay? You can't express v2 in terms of v1, okay? You can't take the linear combination of okay, or you can say you can't multiply something and you can get v1 or v2, okay? That you have to remember. But suppose you have got three vectors, right? v1 equal to 1 0, and v2 equal to 0 1, and v3 equal to 3 and 4, right? So see, you can get this vector v3, okay? You can get this vector v3 by taking the linear combination of these vectors. How? You see, v3 can be obtained by just multiply this by 3 times 1 0 plus 4 times 0 1, right? You see, this is the linear combination, okay? So you are taking linear combination of 3v1 plus 4v2, and you are getting this vector v3, right? So what you can comment on here, guys, these set of vectors, okay, these set of vectors are not linearly independent, they are linearly dependent, okay? और आप यहाँ पर ऐसा भी देख सकते हो कि जैसे ही वेक्टर गिवन है तो यू कैन फॉर्म अ मैट्रिक्स, मैंने आपको बताया भी था लास्ट टाइम, यू कैन फॉर्म अ मैट्रिक्स दैट इज 1 0 0 1 एंड 3 4, ठीक है? तो आप देखो यहाँ पर 1 0, सो यहाँ पर क्या है, व्हाट इज द ऑर्डर ऑफ द मैट्रिक्स, यू सी 2/3, ठीक है? तो यहाँ पर व्हाट कैन बी द रैंक ऑफ दिस मैट्रिक्स, आपको पता भी है कि रैंक ऑफ द मैट्रिक्स कैन बी मैक्सिमली 2, राइट? तो पक्का यहाँ पर फ्री वेरिएबल आने वाला है ना? तो एक you can say pivot, this will be the pivot, so there will be a free variable, right? अगर free variable है, certainly it will be what? LD. It cannot be it cannot be linearly independent, ठीक है? तो जब number of equations are less than number of unknown, तो they are linearly dependent vectors. ये आप याद रखना, ठीक है? यहाँ पर number of rows are what? Number of rows are less than the number of unknown, right? See, they are linearly dependent, याद रखना, okay? तो मान लो आपके पास यहाँ पर क्या दिया हुआ है, there are 3 vectors in R2, right? There are 3 vectors in R2 plane, right? 2 plane means 2-dimensional vectors are given, ठीक है? So if you are able to express any vector as a linear combination of other vector, मतलब they are not linearly independent. If you are not able to express them as a linear combination, okay, that is called linearly independent. So it's a very simple definition, okay, that you have to remember, ठीक है? और मैंने मैथमेटिकल डेफिनेशन दे दिया था कल, राइट? तो मैथमेटिकली आप क्या बोल सकते हो कि suppose you have got any set here, right? Set v1 v2 and so on vn, right? So they are linearly independent if their linear combination, if the linear combination of you can say alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 and so on alpha and vn go to 0, okay? Linear combination is equal to 0 means you don't want any kind of linear combination, remember, right? Means none of the vector can be written as the linear combination of another vector. That is the meaning of this expression, right? Alpha 1 v1 plus alpha 2 v2, that's okay. when it is gonna be true, if and only if, remember, v1 and v2 dot dot vn, these are not zero vectors, right? अब मान लो अगर कोई एक जीरो वेक्टर प्रेजेंट है, ठीक है, if there is a zero vector present, ठीक है, so certainly it is going to be what, the LD vector. I will to show you, right? So alpha 1 v1, these are not linearly, you can say, uh, v1 v2 v3 are not non-zero here, okay? So alpha 1 equal to alpha 2 equal to dot dot alpha n should be equal to 0, okay? I hope this makes sense to all, right? So it's a very important concept, right? So before this, we will talk about span as well, okay? Span. So this was one of the important concepts that you have to remember, and we will see some of the examples as well, okay? Okay, so मान लो आपके पास एक एग्जांपल लेते हैं, just to check whether it is a Li vector or not. और आपको ये आज स्पैन का कॉन्सेप्ट समझ आ जाएगा, स्पैन क्या होता है, ठीक है? इट इज आल्सो रिलेटेड विथ लीनियर कॉम्बिनेशन, राइट? लीनियर कॉम्बिनेशन से रिलेट करता है स्पैन। तो आज शिवम का कल एक क्वेश्चन था कि सर कैन वी हैव लैम्डा 1 लैम्डा 2 लैम्डा 3 लाइक इन केस ऑफ इन्फिनिटली मैनी सॉल्यूशंस, मान लो you are investigating the value of lambda 1 lambda 2 lambda 3, right, while writing them as a linear combination. तो क्या infinitely many solutions are possible for lambda 1 lambda 2 lambda 3? तो आज के सेशन में आपका क्लियर होने वाला है, ठीक है, समझ आया ना? तो यहाँ तक सबको समझ आ गया क्या? प्लीज लेट मी नो इन द चैट बॉक्स। तो लीनियर इंडिपेंडेंट होता क्या है, ठीक है? लीनियर इंडिपेंडेंट का मतलब है कि none of the vector can be written as linear combination of other vectors, ठीक है? जो भी वेक्टर सेट में दिए रहेंगे, सेट में मान लो दो तीन वेक्टर दिए हैं v1 v2 v3, and if you are not able to write, suppose v3 is, you are not able to write v3 as a linear combination of v1 and v2. linear combination का केवल टू ऑपरेशंस आर देयर, याद रखना। लीनियर कॉम्बिनेशन में हम लोग दो चीजें करते हैं, एक मल्टीप्लाई करते हैं स्केलर से और एक ऐड करते हैं, राइट? कितना सिंपल है ना? और लीनियर कॉम्बिनेशन इज थ्रू आउट दी लाइफ, पूरे लाइफ में आपके लीनियर कॉम्बिनेशन आने वाला है, ठीक है? तो लेट मी टेक द एग्जांपल हियर सो दैट यू गाइस कैन अंडरस्टैंड। तो मान लो कोई बोलता है कि आपके पास सेट गिवन सेट ऑफ वेक्टर्स, दिस इज सेट, ओके? The vectors are present 1 2 3, right? 0 1 2. See, vectors are present in the form of coordinates, right? So you can write them as a column vector, right? You can take the transpose of them, okay? And minus 2 0 1. So these are the components which are given. So this is a set of vector which is given here, right? Now the question is whether they are Li or LD, Li or LD, right? Whether they are Li or LD. You see here there are three vectors and three dimensional space is there, right? So see, you can find the determinant by forming the matrix. Quickly you can determine whether they are Li or LD whenever they are they are forming a square matrix, right? Or you can say number of vector is equal to you can say in the vector space R3, right? There are three vectors in R3, okay? So what you can do, the very first step that you can do here is step number 1. The very first step is what? You can form a matrix, right? So you can say this is v1, this is v2, this is v3. तो आप यहाँ पर लिख सकते हो v1 v2 v3, ठीक है? तो आप मैट्रिक्स आपका आ जाएगा, that is 1 2 3 0 1 2 minus 2 0 1, right? minus 2 0 1, right? अब आप यहाँ पर एलिमिनेशन लगा सकते हो and you can see whether if three variables are there, मतलब they are not linearly independent, ठीक है? या कि आप डायरेक्टली मैट्रिक्स निकाल लो, ज्यादा अच्छा रहेगा, ठीक है? ओके, as this is a square matrix, right? स्टेप नंबर 2 में क्या रहेगा? क्विक, ओके, यू कैन फाइंड द डेट निकालेंगे तो क्या हो जाएगा? 1 times 1 minus 0, और ये तो 0 ही रहेगा, and -2 times 4 minus 3, right? तो ये क्या आ रहा है guys, right? This is nothing but 1 minus 2, which is -1, okay, which is not equal to 0, right? If determinant is not coming out to be 0, means what? The rank of the matrix क्या हो जाएगा? Rank of A will be equal to 3, right? Which is number of unknown. Okay. If rank is 3, which is equal to number of unknown, right? You will get unique solution as well, and these vectors are Li vectors, you can say. Li. याद रखना. This is very important. Okay. These vectors are Li vectors. Understood or not? Please let me know, right? I think this is clear for all. So these are the column vectors they have given. Sometimes they might also give you row vectors, right? They will mention whether these are row vectors or column vectors. See, these are column vectors. If nothing is mentioned, just consider column vector, right? If row vectors are mentioned, you put row, okay, like this. And then if square matrix is there, okay. So let me tell you how to find whether it is having free variable or not. In this case, no free variable, ठीक है. और स्क्वायर मैट्रिक्स है तो आपको अच्छा है कि डायरेक्टली यू जस्ट फाइंड डिटरमिनेंट 3/3 का. अगर 3 वेक्टर्स आर गिवन, मैक्सिमम 3 वेक्टर्स इन द एग्जाम दे माइट गिव, और 4 वेक्टर्स आल्सो. डोंट वरी, दे विल नॉट गिव मेनी वेक्टर्स, ठीक है. ओके, तो आपको सेट ऑफ वेक्टर दिया रहेगा और they will ask you whether these vectors are linearly independent or not. Last time we have done one example. If vectors are given and some element will be unknown, right? In that some component is going to be unknown, right? And they will say these vectors are linearly dependent vectors. Linearly dependent का मतलब क्या है? Determinant is equal to 0, बस unknown आप निकाल सकते हो, ठीक है. तो याद रखना ये सारे पॉइंट्स, ठीक है. ओके, सो आई होप दिस मेक सेंस टू ऑल. अब मान लो ऐसा क्वेश्चन है, एक क्वेश्चन मैं लेता हूं, बहुत ही सिंपल क्वेश्चन है. एग्जाम्पल नंबर सेकंड. Next example I'm going to take here. Suppose we have got here 1 minus 1 1, right? And this is 4. This is one vector, right? Set of vectors are given, you can say 1 minus 1 1, and next vector is 4 1 2, right? 4 1 2. Next vector is given as 2 minus 3 and 3, right? And next vector is 2 1 0, right? So you see here how many vectors are there. Acha, please tell me how many vectors are there, and what is the dimension, what is the vector dimension here. I mean, you can say there are four vectors in R3. 4 vectors in R3. Yes, 4 vectors in R3, right? Okay. So if you see the, if you make the matrix here, right? If you prepare a matrix, right? So क्या डायमेंशन होगा इसका? I mean, the size of the matrix क्या आएगा? 3 cross 4, right? अब 3 cross 4 है, आप देखो यहाँ पर 3 cross 4, right? So what can be the rank of the matrix? Maximum rank can be 3, right? तो पक्का एक फ्री वेरिएबल तो आना फिक्स है, राइट? तो इन दिस केस यू डोंट हैव टू इन्वेस्टिगेट एनीथिंग, यू कैन डायरेक्टली से दैट दे आर लीनियरली डिपेंडेंट वेक्टर्स. आप यहाँ पर डायरेक्टली बोल सकते हो कि दे आर लीनियरली डिपेंडेंट वेक्टर, राइट? दे आर लीनियरली डिपेंडेंट वेक्टर. आपको कुछ भी नहीं करना है, क्योंकि सर्टेनली यू विल गेट व्हाट, यू विल गेट ठीक है, फ्री वेरिएबल्स हियर. आप देख भी सकते हो, एक मैट्रिक्स फॉर्म कर लो. जैसे मान लो मैट्रिक्स फॉर्म किया 1 minus 1 1, 4 1 2, राइट? 2 minus 3 3 and 2 1 0, ठीक है. तो अगर आप ये 3/4 का मैट्रिक्स है, इफ यू परफॉर्म एलिमिनेशन, सो मैक्सिमम 3 pivots can be there, right? Maximum 3 pivots, okay? So you don't have to investigate anything. I have told you last time some the proper methods, okay, to investigate whether they are Li or Ed. ठीक है, समझ आया क्या? तो जब भी ये सिचुएशन रहेगी याद रखना, नोट number of unknown, number of equations, sorry, is less than number of unknown. Right? Number of equations are less than number of unknown. Right? Is this kind of systems are known as what kind of system? Underdetermined system. Okay, these are underdetermined system. Okay, number of equations are less than number of unknown. Right? So underdetermined, and you will get always what they are LD. Okay, please remember this. These are very important points. Okay. And if suppose if two rows are same or two columns are same, right? Okay, or if two rows are proportional to each other, if two columns are proportional to each other, matlab they are not li, right? They are linearly independent, because you know you are able to express, after all we know that vectors are nothing but rows and columns, right? रो इज नोन एज रो वेक्टर, कॉलम इज नोन एज कॉलम वेक्टर, ठीक है। तो आप जानते हो कि अगर डिटर्मिनेंट जीरो आता है, कब जीरो आता है, वी हैव सीन द प्रॉपर्टीज राइट ऑफ द डिटर्मिनेंट, कि जब दो रोज सेम रहती हैं, कि you know one row is you are able to express one row as a linear combination, I mean as a combination of some other row, right? Okay, by multiplying some scalar or something, right? So if one row is proportional to each other, proportional to some other another row, right? तो आप बोलते हो कि you know that is gonna be zero, ठीक है। तो they are LDs, right? तो जो भी कॉन्सेप्ट हम लोग सीख चुके हैं, now we are you know again utilizing those concepts, ठीक है। समझ आए क्या? Please tell me fast. Yes. So any question you can do based on linearly independent now? Please tell me. Yes, very good, very good. अब बात करेंगे यार लीनियर स्पैन की, लीनियर स्पैन, और लेट मी टॉक अबाउट लीनियर कॉम्बिनेशन अगेन। लीनियर कॉम्बिनेशन, ओके, लीनियर कॉम्बिनेशन और लीनियर स्पैन, दे हैव everything common in between, right? लीनियर कॉम्बिनेशन एंड लीनियर स्पैन का मतलब क्या होता है, आज आपको क्लियर होने वाला है, राइट? ठीक है, मैंने आपको एक चीज बताया था कि जब आप वेक्टर स्पेस डिस्कस करते हो एंड यू टॉक अबाउट R2 वेक्टर स्पेस, राइट? तो यू हैव सीन वन लाइन, एक लाइन आया था, उसको क्या बोलते थे? सब स्पेस बोलते थे, राइट? दैट वाज सब स्पेस, राइट? लाइन यू वर गेटिंग, दैट वाज सब स्पेस, ओके। अब वो हाउ यू वर गेटिंग दैट लाइन, ये भी एक इंपॉर्टेंट क्वेश्चन है। हाउ यू वर गेटिंग दैट लाइन, ओके? जस्ट बाय मल्टीप्लाइंग सम you know स्केलर कांस्टेंट विद वेक्टर, राइट? जब आप किसी वेक्टर से स्केलर कांस्टेंट मल्टीप्लाई करते हो तो लाइन एक मिलती है ना, एंड दैट लाइन पासेस थ्रू ऑरिजिन, दैट लाइन पासेस थ्रू ऑरिजिन। तो लीनियर कॉम्बिनेशन, तो आपको पता ही है क्या होता है, जब सेट ऑफ वेक्टर गिवन रहेगा तो यू कैन एक्सप्रेस you know you can write like this, suppose you have got vectors like this, okay, you know v1 v2 and so on v3, right? They belong to some vector v, and there are scalar like alpha 1 alpha 2 and so on, you know they belong to you know kind of you can say real set. I'm not considering complex, there can be complex as well, but I'm focusing on real, okay, real number. So you can write them as a linear combination. So linear combination is nothing but you can say LC is going to be v1 alpha 1 v1 plus alpha 2 v2, right, plus alpha 3 v3 and so on. So linear combination has got two things, okay, like multiplying by scalar and add, okay. So two operations are there, ठीक है, सिंपल सा मेथड है, टू ऑपरेशंस आर देयर, राइट? टू ऑपरेशंस आर सिंपल, राइट? आपको ये याद रखना है, दे आर, इट इज वेरी सिंपल, राइट? ओके, so it's a very simple approach, right? So linear combination of handful of the vector, right? generate infinitely many vectors. आप याद रखना, if you have the linear combination of some vectors, right, so you can generate infinitely many vectors, right, infinitely many vectors. कैसे देखो, मान लो आपके पास एक वेक्टर दिया है, सपोज एग्जांपल, लेट मी टेक एग्जांपल्स। सपोज आपके पास कोई एक वेक्टर है 2 -1 and 1, ठीक है, you have got 2 -1 and 1, right? So you can get infinitely many vectors from this vector. You know what? Okay, how? You can multiply by the scalar. अगर आप इसमें a से multiply करते हो, so this vectors will become what? You can say 2a minus a and a, right? So you can take many values of alpha, or you can say a, right? So you can get infinitely many values, right? Okay, I hope this makes sense. So आप जहां भी infinitely many solutions देखते हो, right, infinitely many solutions, okay, ठीक है, तो आप क्या करते हो कि वहां पर अल्फा टाइम्स some vectors are there, right? Okay, so there are many infinitely many solutions are possible, right? Infinitely many vectors you can get, right? If you have one vector, so you can multiply by some scalar constant, so you can get infinitely many vectors, right? That is what the story here is, ठीक है। You can also write, suppose जैसे मान लो ऐसा है, second example you can say 2 times of any vector you take, like 5 3 and -4 plus 3.5 times 2 -1 and -2, okay. So what is this? This is a linear combination here. You can say this is alpha 1 v1 plus alpha 2 v2, right, is equal to what? The new vector you can say that is 17 2.5 and -15, right? You can do like this, okay, understood. So what is the conclusion here? You can write always linear combination linear combination linear combination of handful vector, the linear combination of handful of vectors, okay, generate infinitely many vector, you can say, vectors, okay. So remember, if you have got one vector or if you have got two vectors, so you can take the linear combination of them and you can fill entire space. It is just like filling the space. Suppose आपके पास कोई एक स्पेस है और आपके पास दो ही वेक्टर अवेलेबल है, तो आप उन दोनों वेक्टर में मल्टीप्लाई स्केल करके, स्केल एंड ऐड करके पूरे स्पेस को फिल कर सकते हो, ठीक है, जस्ट बाय टेकिंग द लीनियर कॉम्बिनेशन ऑफ दोज वेक्टर्स, ठीक है। So linear, keep in mind this is very important to remember, okay, let me hide here, yeah. So linear combination of handful of the vectors generate infinitely many vectors, and one more line I will say, linear combination is the essence of linear algebra, guys. This is one of the important concepts, one of the powerful concept of linear algebra, ठीक है, याद रखना। I hope this makes sense to you, right? ये बहुत ही इंपॉर्टेंट है, ठीक है। So now I'll talk about span. अब देखो स्पैन का मतलब क्या होता है। स्पैन एक नॉर्मल लैंग्वेज में मैं बताता हूं आपको। देखो लीनियर कॉम्बिनेशन का मतलब क्या होता है, यू हैव गॉट द सेट ऑफ वेक्टर्स, यू कैन गेट एनी वेक्टर बाय टेकिंग देयर लीनियर कॉम्बिनेशन, ओके, अंडरस्टूड, ओके, यू कैन टेक द लीनियर कॉम्बिनेशन ऑफ अदर वेक्टर्स, ठीक है। स्पैन का मतलब होता है कि द स्पैन इज नथिंग बट व्हाट, the span of a set of vector, the span of set of vectors, the span of set of vectors is what? Is the set of all vectors obtainable, okay, obtainable by a linear combination of the original vector. Suppose you have got suppose you have got the original vector, right? So if you are able to get all possible linear combination, right, all possible linear combination, एक से नहीं काम चलेगा, ठीक है? तो मान लो आप जो स्केलर कांस्टेंट है, यू वेरी मैनी, ओके, लाइक यू नो, सपोज आपके पास 1 2 वेक्टर दिया हुआ है, so if you multiply by scalar constant like alpha, right, so you can get many linear combination, right? So this is nothing but what you can create many vectors. स्पैन का मतलब क्या होगा? क्रिएट और जनरेट, यू कैन से, राइट? तो क्रिएटिंग और जनरेटिंग, राइट? सो फ्रॉम ओरिजिनल वेक्टर you can create many vectors, right? And you can fill the space, ठीक है? जैसे अभी लीनियर कॉम्बिनेशन में हम लोग क्या कर रहे थे, एक वेक्टर दिया हुआ है, राइट? वी आर टेकिंग द लीनियर कॉम्बिनेशन ऑफ अदर वेक्टर एंड वी आर जनरेटिंग सम अदर वेक्टर, राइट? ओके, दैट इज आल्सो काइंड ऑफ स्पैन ओनली, राइट? तो अगर आप ऑल पॉसिबल लीनियर कॉम्बिनेशन आप लेते हो, you know, you can take any possible linear combination, right? Or you can fill the space, okay? So this is very important to remember, right? So it's a very important choice, okay? मान लो ऐसा हम बोलते हैं कि एग्जांपल लेते हैं, तो आपके पास एक एग्जांपल है, एग्जांपल कि मान लो आपके पास दो वेक्टर हैं, v1 is given as 1 0 and v2 is given as 0 1, right? So if I want to find the span of this, first of all write the linear combination of them. So you can say alpha 1 v1 plus alpha 2 v2 will be equal to what? Alpha 1 alpha 2, right? Now you can take alpha 1 alpha 2 anything, right? Okay, I'm not taking particular value of alpha 1 and alpha 2, I can take any value of alpha and alpha 2, right? Okay, so all possible linear combinations, okay, all possible linear combinations, not one linear combination. Span का मतलब होता है कि all possible linear combination you can take and you can fill the entire space, ठीक है? तो from one vector you can get many vectors. If you have two vectors, you can take the linear combination of those vectors and you can get many vectors, right? You can fill the entire space, ठीक है? तो मैं एक एग्जांपल लूंगा, सिंपल से एग्जांपल आई विल जस्ट टेक, ओके, सो दैट यू गाइस कैन अंडरस्टैंड ज्योमेट्रिकली, ठीक है? एक एग्जांपल अपन लेंगे, simple example, just I'm telling you, right? You see, geometrically we have to understand, okay? Though I have explained also those things, लेकिन span को हम geometrically कैसे समझते हैं? Geometrically, suppose you take R2 plane. R2 का मतलब क्या होता है? This is x, this is y. You take R2 plane, okay, and this is x, this is y, right? Okay, and you take suppose one vector, you take, right? This is 1 and you can say this is 2. So I'm taking one vector here, that is nothing but what? 1 and 2, 1 comma 2 you can say, okay? Now if you multiply with this vector any you know scalar, that is alpha, you can say, right? So alpha can be anything, right? Alpha can be positive, alpha can be negative, alpha can be 0. So what you will get here is, if you multiply something positive here, your vector will go like this, in this direction. Your vector will go in this direction, right? If you take all possible you know value of alpha, right? All possible value of alpha, okay, understood? So please remember these points are very important. So if I ask you what is the span of the vector 1 and 2, what is the span of the vector 1 and 2, right? So you can say that the span of vector 1 and 2 is going to be a times 2a, right, where a is nothing but real number. ठीक है, किसी वेक्टर का स्पैन कैसे लिखते हैं याद रखना है, ये समझ आया क्या? अगर मान लो स्पैन ऑफ 1 2 कोई पूछ रहा है, मतलब आपको एक अननोन से एक वेक्टर है, सिंपल एक वेक्टर है, यहाँ पर तो आप कोई लीनियर कॉम्बिनेशन तो लेने वाले नहीं हो, राइट? आप क्या करोगे, स्पैन ऑफ 1 2 का मतलब होता है simply you multiply one scalar constant and you will get what? Can you tell me here what you will get here? You will get one line. What you will get here? You will get one line. समझ आया ना? You will get one line and this line is nothing but the span. This line is nothing but what? Span. Okay, please remember, because you are generating one line from one vector, right? So span 1 2 का मतलब है a times 2a, that is a times a is what? R. ठीक है, so already we have seen how we get this line, right? This line is nothing but a subspace. ठीक है, and this subspace is going to be this line is passing through origin, right? तो आप समझ सकते हो कि यहाँ पर सारे कॉम्बिनेशन हम ले रहे हैं, सारे वैल्यूज, all possible values we are taking, and from one vector we are creating many vectors, right? ठीक है, so we call this line as a span. So span is what? Span is line here. Okay, geometrically you can say, and this line is nothing but a to a, right? A to a. I think this is clear. मान लो एक स्पैन तो आप ऐसा बोल सकते हो, स्पैन ऑफ, मान लो कोई पूछता है स्पैन ऑफ 1 2 क्या होगा, इट इज स्पैन ऑफ 1 2, राइट? दिस वेक्टर 1 2, this is set of vector, right? Only one vector is there, so span of 1 2 will be a times 2a. मान लो कोई पूछता है कि स्पैन ऑफ 2 वेक्टर्स आर गिवन, मतलब ऐसा है 1 2 and comma you can say that 2 5. अगर मान लो इनका स्पैन पूछता है तो क्या करोगे आप? What you will do? You will multiply with some constant here, right? With vector 1. You will take the linear combination, obviously, right? You will say you know, a times first and b times second, right? ठीक है, what you will do here? You will say that the span is going to be what? A plus 2b, okay, and 2a plus 5b, right? समझ आया ना? आप क्या करोगे, एक a लोगे, a is a scalar constant, you will multiply with first vector, and b is a scalar constant, you will multiply with the second vector, and you will take the linear combination of them, right? So this is just a span. Okay, so you will say that a and b are the real number. ठीक है, okay, so infinitely many solutions जब आता है, मतलब समझ जाओ कि that is denoting what? Span. Okay, span, infinitely many solutions. इसका स्पैन क्या होगा? अच्छा, इसका स्पैन क्या होगा? देखो ज्योमेट्रिकली अगर ये स्पैन है a plus 2b 2a plus 5b, this is just a span. Okay, you take two vectors, right? You can add them. Okay, you can add them, right? So देखो 2 vector 3 vectors you can realize easily, right? है ना, आप 2 vectors को ऐड कर सकते हो, 3 vectors को ऐड कर सकते हो, आप ज्योमेट्री देख सकते हो, बट इट इज वेरी टफ टू रियलाइज बियॉन्ड अगर आप 3 डायमेंशन से ज्यादा जाते हो आगे, तो वहां पर हम लोग ज्योमेट्रिकली नहीं समझ पाते हैं, राइट? ये समझना है, ठीक है? ओके, तो इसका स्पैन देखो, ये स्पैन अगर कोई पूछता है 1 2 2 5, और मान लो कोई पॉइंट है इस वेक्टर में, कहीं भी कोई एक पॉइंट है, राइट? कि क्या इस पॉइंट को हम लोग एक्सप्रेस कर सकते हैं, दिस पॉइंट को? ओके, ओके, with these this span, right? With this point. Okay, so what you can do, you can compare this, right? Okay, suppose this point is nothing but you can take -3 -1, right? So आपका क्या है यहाँ पर? स्पैन है, ठीक है? You have got this span of this is nothing but a times, देखो मैंने क्या किया यहाँ पर, सिंपल सा स्पैन का मतलब मैंने आपको बताया कि लीनियर कॉम्बिनेशन, ऑल पॉसिबल लीनियर कॉम्बिनेशन, राइट? So suppose any point is given, right? Like दैट इज कोऑर्डिनेट बट दैट इज जस्ट अ वेक्टर, ठीक है, वो वेक्टर ही है। तो आप यहाँ वहां से ए और बी की वैल्यू फाइंड कर सकते हैं क्विकली, राइट? यू कैन फाइंड द वैल्यू ऑफ ए एंड बी, राइट? सिंपल, ठीक है, फाइन। So by taking the linear combination you can get any other vector, right? मान लो जैसा मैं ये बोलना चाहता हूँ कि suppose you have got span of, this is the vector 1 2 and what is this 2 5. This is span, okay? Span of this is what? Span of this is, you can say I can say that span of this is going to be a times a vector 1 2 and b times the vector 2 5. Okay, and remember, can we get another vector? You can say this vector I am talking about, this vector, can we get this vector by taking the linear combination of by taking the linear combination of 1 and 2 2 and 5? You will say yes, ठीक है, कैसे देखो, you will say here minus -3 and -1, right? So all possible linear combination you can take and you will get this, right? So you find the value of a and b now, right? What is that a and b? What is that particular a and b that is going to give you -3 and -1? ठीक है, तो अगर कोई span of this पूछता है तो you can say just by multiplying and take the linear combination, that is the span, ठीक है? span का मतलब समझ आया क्या? So you can say that a plus 2b, a plus 2b and 2a plus 5b is going to be equal to -3 -1. अब हमें तो ऐसा लगता है कि तो बहुत सिंपल है, a plus 2b equal to -3, 2a plus 5b equal to -1. So I think anybody can solve this equation. Can you solve Shivam and अच्छा these equations and tell me what is the value of a and b? यहाँ पर a की वैल्यू क्या है and b की वैल्यू क्या है, ठीक है? Because this is just a pair of linear equation that you can solve, ठीक है? So if you want to fill entire space, आप याद रखना, अगर आप पूरे स्पेस को फिल करना चाहते हैं तो आपको स्पैन की जरूरत पड़ेगी, ठीक है? क्योंकि यू कैन टेक एनी कॉम्बिनेशन, एनी लीनियर कॉम्बिनेशन, राइट? ऑल द लीनियर कॉम्बिनेशंस आर पॉसिबल, ठीक है? So in case of R2, okay, in case of R2, please remember this point. So I have given you all the examples here, right? Okay. तो कोई मान लो पूछता है वेक्टर R2 दिया है, राइट? और मान लो पहला वेक्टर दिया है, एग्जांपल से मैंने आपको बता दिया कि V वेक्टर इज देयर, दैट इज 1 2. कोई पूछता है व्हाट इज द स्पैन ऑफ 1 2, राइट? हाउ टू फाइंड स्पैन ऑफ 1 2? Span of V you will write, span of V you will write like this. In the set you have to write always, right? Span of V in the set you have to put, right? तो आप span इसका लिख सकते हो, क्या हो जाएगा? A times 2A, simple, and you will get one line, you will get one line, ठीक है? And you can also mention here such that A is basically the real one, आप ऐसा बोल सकते हो, this is span, ठीक है? And the second one is जैसे मान लो एक क्वेश्चन मैं लेता हूं ऐसा, is 3 6, okay, 3 6 in the span, okay, in the span, okay, 3 6 in the span, you see 3 6 in the span that you have to take care of. You can say that yes, it is in the span. How? You take 3 common, right? You take 3 common here, तो आप यहाँ पर 3 कॉमन लोगे तो क्या है 1 2 है, राइट? तो या इट इज इन द स्पैन। समझ आया क्या ये चीज? बताओ, मान लो एक वेक्टर v दिया है 1 2, नाउ दे आर आस्किंग इज 3 6 इन द स्पैन, मतलब ये जो 3 6 है ये स्पैन में है कि नहीं है? तो या इट बिलोंग्स टू स्ट्रेट लाइन ना, यू टेक 3 कॉमन, 3 times 1 2 is yes. लेकिन अगर कोई पूछता है कि इच, ये पहला क्वेश्चन है, इज 210 vector 210 in the span? Tell me, अच्छा and Shivam, please tell me 210 is in the span of this V. बताओ. Can we create this 210 with the help of this V by anything, by doing some simple operation? Tell me fast. You are saying yes. How it is? Yes. 210 में क्या 2 कॉमन लोगे तो 1 5 आ रहा है ना. हाँ, you can take 2 कॉमन. Are you getting the same vector here V? मेरा कहने का मतलब क्या है, दिस इज अ V वेक्टर, राइट. तो आपके पास V वेक्टर है, you have got V vector, you multiply anything, you will get straight line. Now you have got 210, right? 210 is there. Is 210 in the span? तो आप देखोगे यहाँ पर, if you take 2 common here, so it is 1 5, but this is not the vector given. Okay, this is some other vector, right? This is some other vector, guys. Okay, please remember this. So this is not in the span. Yes, this is not in the span. That you have to remember all these points. ठीक है. Okay, so these points are important to understand. Okay, ये questions आप कर सकते हो. समझ आया क्या, बताओ. Why? Yeah, it's a very good point, right? देखो, let me show you. See, जैसे मान लो ये तुम्हारा x है, ये y है, और मान लो तुम्हारा 1 and this is 2, right? So this is the vector that you have got, right? If you multiply 2 3 scalar multiplications, you will get this kind of a thing, right? Situation, both direction you will get, right? Now you have been given a point. क्या दिया है यहाँ पर? 210 दिया है, 210. तो आपका 2 यहाँ पर है, 2 यहाँ पर है, this is 2, you can say 1 2, and 10 कहाँ पर आएगा? ऊपर. तो आप जाओगे, please remember this. So somewhere here you will get, right? And this point is not on this line, right? ये point आपके इस line में नहीं है. Am I correct or not, right? देखो, कोई भी वेक्टर दिया है, उसका स्पैन क्या हो सकता है अगर वो 2 डायमेंशनल का वेक्टर है, सिंगल वेक्टर. इफ यू कैन मल्टीप्लाई एनी स्केलर कांस्टेंट, राइट? अब आपके पास वेक्टर दिया था क्या? द वेक्टर वाज, you see, this vector is nothing but this, and we are considering is this 210 is in the span. इस स्पैन में है कि नहीं है, आपको ये देखना है, राइट? ठीक है. ओके, अंडरस्टूड. तो बहुत ही इंपॉर्टेंट है, that you have to keep in mind, right? So this vector 1 2 you are not getting back. Okay, so this line I'm talking about whether that vector lies on this line or not. So it does not lie. इस लाइन में नहीं लाई करता. ओके, तो क्वेश्चन आपके पास ऐसे आएंगे. मैं आपको कुछ क्वेश्चन दे देता हूं, यू हैव टू जस्ट फाइंड आउट, राइट? मान लो you have got vector v1 that is 1 2, right? And vector v2 that is 2 5. आपके पास दो वेक्टर दिए हुए हैं, और इसके स्पैन अगर कोई पूछता व्हाट इज द स्पैन ऑफ v1 एंड v2, राइट? तो स्पैन ऑफ v1 एंड v2 क्या हो सकते हैं, आप बताओगे. स्पैन ऑफ v1 and v2 is nothing but the set, okay, of by taking the linear combination of them. So you take a plus 2b and 2a plus 5b, right? So by taking the linear combination of them, such that here you can say that a and b are nothing but real number, right? So this is a set kind of, right? Now the question is what? The a question you can say is 3 6 is 3 6 in the span, right? Okay. Second question is 2 and 5 in the span, right? Okay. And next question is C question, you can say, is 210 in the span, right? So ये सारे questions हैं, these questions you can take a look, right? Okay. Now let me talk about some examples of R3. Examples of R3. So 1 minute, guys. Okay, fine. So example of R3 is what? Suppose there are some vector, like you can say V1 is given as, okay, 1, 2, 3, right? V2 is given as 3, 2, 4, and 2, 3, 4. Yeah. 2, 3, 4. And okay, so these are two vectors we have been given, right? Two vectors are given. Now they're asking span of V1 and V2. Span is nothing but the linear combination, guys. All possible linear combinations. ठीक है? Span का मतलब कुछ नहीं है. Span का मतलब क्या है? All possible linear combinations, right? All possible linear combinations. ठीक है? So V1 and V2, right? V1 and V2, right? So what is the span of V1 and V2? So span of, V1 and V2 is nothing but the set, right? You can say A plus 2B, 2A plus 3B, 3A plus 4B, right? Where A, B belongs to R, real number. Okay. Now the question is, a question you can say is 2, 8, 10 in the span, in the span, okay? So by taking any linear combination, can you get 2 at 10? That is what the question is, right? You take any linear combination, you should get 2 at 10. If you're not getting 2 at 10, means that is not the linear combination, right? That is not in the span, that you can say, right? Okay, please remember these points. जैसे मान लो ये क्वेश्चन था, राइट? जैसे 3, 6 है, ओके, 3, 6. तो मान लो तुम्हारे पास a plus 2b है and 2a plus 5b है, so 3 and 6. So if you try to solve this, okay, so you should get some values of a and b, right? If you're not getting a and b values, right, then that is not in the span, that you have to remember, okay, right? There is no combination is available, okay? If you try to solve this, what will be, solution? You can say you just multiply by 2 here, so 2a plus 4b equal to 6, right? And this is going to be 2a plus 5b equal to 6 only, right? So यहाँ पर अगर इसको कट कर देंगे तो यहाँ कितना आ जाएगा? माइनस b equal to 0. v equal to 0 you are getting, right? v equal to 0, okay? And if you put v equal to 0 here, so a equal to 3. Yes, so this is in the span, you can say, right? It will be in the span. But if you compare this to 5, right, you can take 2, 5 as well. Okay. So a plus 2b and 2a plus 5b, right? 2 and 5. So again you do all those things, right? So 2a plus 4b equal to 4, right? And this is nothing but 2a plus 5b equal to 5. Minus minus minus, right? So minus b equal to minus 1. So again you might get, right? So here also, this is also, so you can check like this, okay? It is very simple. If you are getting some value of a and b, right, okay, so means you are able to express that given that vector belongs to, you can say you are able to take the linear combination of them, right? अब अगर 210 आप लेते हो, 210, right, you take 210, ठीक है, so you can take 210 here, okay, and you will get something, okay, चलो. So I will share the assignment also, guys, based on this, right? So you guys can solve the assignments, okay. Okay, so I believe this is fine for all, and next one is the example that I have given you. These example you can try, okay, at your own space, okay, और मुझे आप बता सकते हो, ठीक है. तो मान लो हम एक सेकंड एग्जांपल लेते हैं, सेकंड क्वेश्चन फॉर द यू. आपके पास v1 दिया है 100, right? v1 is 100 and v2 is 010 and v3 is what, 001. Our question is x by g in the span, ठीक है. तो आप देख सकते हो कि these vectors are some sort of standard vectors, right? आपको पता है 1 0 0 0 1 0 0 0 1. तो x by g स्पैन में है, मतलब आपको ये समझना है कि x by g को आप लिख सकते हो क्या एज अ लीनियर स्पैन ऑफ दिस. क्या आएगा, पहले आप निकाल लो स्पैन ऑफ दिस, राइट, and then you can check whether this guy is in the span of, okay. So it's a very important thing, fine. So I think this is clear for all, right? So अगर हम बात करें इन टर्म्स ऑफ मैट्रिक्स की, राइट, इन टर्म्स ऑफ मैट्रिक्स की अगर हम बात करते हैं तो याद रखना सम इम्पोर्टेंट पॉइंट. Okay, you try these questions. If you're not able to solve, right, you can let me know, right, so that I will solve it. Important point क्या है यहाँ पर, आप बता सकते हो कि the span of all column matrix. मान लो आपके पास कोई एक मैट्रिक्स है, उसके सारे वेक्टर्स दिए हुए हैं, राइट, तो आप बोल सकते हो कि the span of all the column of a matrix, okay, all the column of a matrix is called column space, ठीक है, कॉलम स्पेस हम लोग बोलते हैं, ठीक है, ओके. इट इज वेरी इंपॉर्टेंट, राइट. सी ax इक्वल टू बी, सपोज आपके पास दिया हुआ है इक्वेशन, तो अगर आप b को लिख सकते हो बाय टेकिंग एनी लीनियर कॉम्बिनेशन ऑफ, राइट, मतलब आप बोल सकते हो कि b इज इन द कॉलम स्पेस ऑफ a. आपका b किस में है, इन द कॉलम स्पेस ऑफ a. सपोज देयर इज नो सोल्यूशन एट ऑल, राइट, सोल्यूशन एग्जिस्ट ही नहीं करता, मतलब क्या है, वो b जो है is not in the column space of A, or you can say B is not spanned by given vector, ठीक है, मतलब B cannot be generated. तो स्पैनिंग का मतलब यहाँ जनरेशन भी होता है, यू कैन से जनरेट करना, राइट, और क्रिएट करना, राइट. और यू कैन से you can fill the space by taking all possible linear combination. तो आई थिंक आपको अब समझ में आ गया होगा, ठीक है. जैसे मान लो आपके पास दिया हुआ है द इक्वेशन ax equal to b, right? The equation ax equal to b is what, the non-homogeneous system of linear equation, right? तो यहां पर हम बोलेंगे the equation ax equal to b has solution only if b lies in the column स्पेस ऑफ ए. अब आई होप आपको ये समझ आ गया होगा ये वाली लाइन, राइट, नहीं तो पहले नहीं आती. अगर हम शुरू में आपको बोलते हैं ना ये सारी स्टोरी, तो आपको समझ नहीं आता ये सर बोल क्या रहे हैं. देखो, अगर आपका जो बी है राइट हैंड साइड, मैं बार बार बोल रहा हूं, इफ यू आर नॉट एबल टू एक्सप्रेस राइट हैंड साइड बी एज अ लीनियर कॉम्बिनेशन ऑफ the column vectors of A, it means there is no solution. और अगर आप if you are able to have the solution, right, if you are getting some sort of solution, it means that B lies in the column space of A. B can be spanned by the column vectors of A, right? The span of all column of a matrix is nothing but the column space. सबको समझ आया क्या ये चीज? सब बताओ जल्दी. आई एम वेरी डिलाइटेड गाइज अगर आपको ये समझ में आ जाता है तो. ठीक है, ओके. So if you want to fill the space, just go for the spanning the space. आप इसको filling the space को हम लोग बोलते हैं spanning the space, right? Spanning the space, filling the space. ठीक है. Perfect guys. So I hope you might have understood everything. ठीक है, तो ऐसे ही पढ़ना है. ऐसे पढ़ोगे तो थोड़ा सा मजा आएगा और समझ में भी आता है. ठीक है, और बहुत सारी चीजें जो हमें पढ़ना है, राइट. अभी तो इन दिस सेशन आई हैव डिस्कस दिस. अभी स्पैनिंग सेट की बात करना है. वी हैव टू टॉक अबाउट डायमेंशन एंड एज वेल एज द बेसिस. तो ओके, तो लीनियर स्पैन और इससे रिलेटेड बहुत सारे क्वेश्चन मैंने आपको दिए हैं. प्लीज ट्राई देम. ओके, अंडरस्टूड. तो these are the situations, right? So so let me write the definition also if you want. तो लीनियर स्पैन का मतलब कुछ नहीं है. लीनियर स्पैन की डेफिनेशन क्या होती है? अगर कोई पूछता है स्पैन ऑफ v1 v2 and so on vn is what? You can say that sum I equal to n, right? You can say lambda I vi. Okay, lambda I vi, where lambda I is nothing but r. So this is nothing but a set, you can say, right? Set. ठीक है, और इसको आप क्या बोल सकते हो? ये कुछ नहीं है, lambda 1 v1 plus lambda 2 v2 and so on and so forth, right? ठीक है, समझ आया क्या? तो कलेक्शन ऑफ ऑल लीनियर कॉम्बिनेशन. लीनियर स्पैन का मतलब क्या होता है? कलेक्शन ऑफ ऑल linear combination, collection of all linear combinations of v1 v2 and so on vn, right, is called you can say the linear span of v1 v2 and so on vn. देखो, you can take the linear combination, that's fine, but collection of all sort of linear combinations जो भी possible है, right, that is the, okay, please remember these things. Okay, understood. तो स्पैनिंग सेट का मतलब क्या हो जाएगा? You will get a set of, you know, vectors, okay, by taking the linear combination of another vectors, right? तो अगर आप all collection of all combination linear combination करते हो तो you will get one set and that is going to be the spanning set, right? That is going to be the spanning set of the vector. ठीक है. okay, please remember this. तो आपके केस में spanning set is nothing but a collection of all the vector which you obtain by taking the linear combination of another vectors, right? So you can write here what is the spanning set as well. The definition of spanning set क्या हो जाएगा? The set v1 v2 and so on vn. The set v1 v2 and that vn is said to form a spanning set, right, of vector space D. Remember guys, we are filling the space by taking all sort of linear combination. का मतलब क्या होता है? We are filling entire space. आपको मैंने एक लाइन शो कर दी है, that is just a span only, right? तो आपको पता होना चाहिए कि all possible linear combination you have to take. Okay, the spanning set, the set is said to form a spanning set of vector space V if for any V, that any small v belong to capital V, right? There exist, okay, these definitions are very tough, right? There exist scalars alpha 1, alpha 2 and so on, alpha n in R, right? Therefore you can say that small v is sum over I equal to n to 1 alpha I vi. Okay. So there are some examples that we will see, okay, and in the next session, and we'll talk about basis and dimension, guys. Okay, so in the next session we will meet and we will see the examples of spanning sets. We will see the examples of spanning sets, right? And then we'll talk about basis and dimension and some other concept you can say, right? So we'll meet in the next session. Thank you for today. If you have any sort of doubt, you can let me know. कोई डाउट है क्या? किसी भी टाइप का डाउट आप बता सकते हो, ठीक है? यस, अगर कोई भी डाउट हो तो बताओ जल्दी, अदरवाइज विल वाइंड अप द सेशन हियर.